So, in our last video, we talked about what the basic idea of a derivative is. Right? We said it's the rate of change of a function. And we looked at this really ugly definition, the limit definition. It's really terrible and not much fun to do. So now we're going to look at some shortcuts, some rules that kind of simplify our life so that we don't always have to look at that limit definition. So, here are just a couple of the basic rules. First, if you have a constant value, just like a is 1, a is 5, a is 100, but it never changes. It's just a constant. The derivative of a constant is 0. The slope of a flat line is 0. It never rises, it never changes. It's just constant. If you have a function x, the derivative of x is just 1. The slope of the line y equals x is 1, right? Y equals 1x. So the derivative of x is just 1. Then, if you have a constant times some function, the derivative of that is just the constant times the derivative of the function. All right, this basically says we don't have to be fancy. A constant multiple just stays a constant multiple. Then this next one says that the derivative of a sum is just the sum of derivatives. Basically, if you've got two functions that you're adding together, the derivative of that bigger function is just the sum of the individual derivatives. So you just put it all together, right? F plus g, the derivative is f prime plus g prime. Then this last one, we often call it the power rule. This is a really important one, very critical to know. The derivative of x raised to the power of n is n times x to the n minus 1. Right? So you bring down, and lower the exponent by 1. Now let's talk about some rules when you have the exponential and logarithm things. So the function e to the x, the derivative of that is e to the x. It is its own derivative, which is a really interesting fact, but also a really wonderful and very useful and helpful fact for us as we go into the future. If you have a constant value a raised to the x, the derivative of this is a to the x, but then it's multiplied by natural log of a. And interestingly, if you used the transcendental number e as this constant a, you would see you get e to the x, natural log of e. The natural log of e is just 1, and you get e to the x as we thought. Then the derivative of the natural log of x is 1 over x. Pretty interesting. We can, of course, look at how to get there through the limit definition, but that's kind of ugly, and we don't need to worry about it. We can just know that the derivative of natural log of x is 1 over x. Next, we're going to look at some trig functions. Again, these rules, you can derive them, but they're kind of a real pain to derive, so just memorize these. So the derivative of sine is cosine. The derivative of cosine is negative sine. You can't forget that negative here. That will mess you up. Finally, the derivative of tangent is secant squared. There are, of course, more, but if you know these three, you can figure out all the others. Next, let's talk about the chain rule. This is a really important idea. If you have a nested function, right, f of g of x, the derivative is f prime of g of x times the derivative of your internal function, the derivative of g prime of x. All right. This rule is very important because it allows us to build up more complex functions, but you can't forget to include this g prime of x here. So like the derivative of e raised to the function of x is e raised to that function times the derivative of the function. Same here, natural log of a function of x is f prime of x over f of x. All right, both of these two come straight from this idea, this first one of the chain rule. It's just kind of showing you a little bit more clearly what to do. Next, product rule. if you have two functions and they're multiplied together, remember if they're added, if it's f plus g, the derivative is just f prime plus g prime. But here they're being multiplied together. So this one becomes a little bit tricky, but there's kind of a simple way, well, I think it's simple, way to remember this derivative. It's the first function f times the derivative of the second times g prime plus the second g times the derivative of the first f prime. So I always say it really fast. First times derivative of the second plus second times derivative of the first. That's a lot. You know, just work on learning it. But basically the idea is you take each of your two pieces, take each of their individual derivatives, and then you kind of play the mix and match game in this form, and that'll get you what you need. Then lastly, we're going to talk about the quotient rule. This is if you have two functions that are being divided. This one, f over g, the derivative is even more complex and ugly. So it's the function g times f prime minus the function f times g prime all over g squared. The g function is squared in the denominator. Again, there are ways to figure out why this is true. I think it's easier to just learn it. And my calc teacher taught us to say, call the bottom one the low function, the top one high. And so you can say low d high minus high d low over low squared. I don't know if that's helpful. That's how I learned it. That's how I remember this. There you go. Those are the basic derivative rules, and with those we can build up all sorts of fancy derivatives and figure all sorts of crazy things out. Just always be careful, always watch out for the chain rule, always watch out for these other rules, make sure you're doing them right, and you'll be good to go. Thanks for watching, we'll see you next time.